All right, it's noon, so we're going to get started. Thank you for joining. We'll be recording this so we can share it with any parents who couldn't make it for the live session today. But glad you could be here, and I'm also glad to have some live audience so that you can ask questions as we go through, because if you have a question, I'm sure someone else has the same question. I probably won't really be able to monitor the chat, so feel free to unmute and ask a question as we move through today. I'll go ahead and share my screen here. And we're going to talk about Singapore math. It's an aspect of our school and our charter that I'm very proud of, that I am very passionate about, that I think is a wonderful thing for our kids. Our recent parent surveys at both West Point and Highbury campus showed that that's an area that some parents would like to get to know more about. So we put together this presentation for you. And by the way, welcome. This is the first time we've been able to join parents from both campuses. It's great to be able to do this and have parents in both places benefit from it. So if you see some unfamiliar names, then, well, we're all getting to know each other, but I'm glad to have people from both campuses here. Okay, this presentation was shared with me by Tricia Salerno. She is a nation-renowned consultant on Singapore math who we've had come visit our school, do trainings with our teachers. She organizes a Singapore Math Summit every year. Teachers across the country come to get training from teachers from Singapore and experts in the United States. She's a wonderful resource, and she's worked with our school closely. So she shared this presentation with me to share with you. I've added a few things in it. If it's got this dark gray background, that's something that I've added to it, but I just wanted to give credit to Tricia for the rest of the slides. So we're going to be talking about Singapore math, which comes from, as you have probably guessed, the country of Singapore, tiny island nation at the very tip of Malaysia. And why Singapore math? What is it about Singapore that makes us want to imitate their method of math instruction? So I'll tell you a little bit about that. The thing that really inspires me about Singapore math and about the story of Singapore as a country is that, to me, it proves that mathematicians are made, not born. Yes, Singapore gets some of the best results in the world in terms of math. They're consistently the top country in the world. Some people, I think, assume, oh, well, people in East Asia are good at math. That's just maybe genetic or something. And what Singapore shows is that is not true. Singapore did not always get great results. In the 70s and the 80s, they were middle of the pack. So in the 1980s, they undertook an effort to write their own math curriculum with a heavy emphasis on problem solving and conceptual understanding. They tried to use best practices and they completely rewrote their curriculum. What happened was pretty remarkable. Starting in the 90s, they shot up in the rankings, and the bottom image you can see there is 1995. They became first in the world in their 4th grade math results, and then it just has continued ever since. So they're continue to be the top. China now sometimes claims to be -- but that's only because they're looking at a very small subset of their students around Shanghai. So Singapore continues to be the top country in the world. So what is it that they did that is working so well for their students? Here's a quote from their Ministry of Education. "Mathematics is an excellent vehicle for the development and improvement of a person's intellectual competence. Mathematics is also a subject of enjoyment and excitement, which offers student opportunities for creative work and moments of enlightenment and joy. When ideas are discovered and insights gained, students are spurred to pursue mathematics beyond the classroom wall." There's definitely an emphasis on the joy of math, of using math to solve problems and kind of wrestling with math and finding new and different ways to solve math problems. So it's very much an exciting thing as an educator to be able to teach students in this method. So why does it work? I'm first going to ask a question up here. Should math instruction focus on memorization or problem solving? The answer that Singapore math gives is yes, meaning both. What it did was it kind of re-emphasized problem solving. In the past, math has been has been taught in a very rote way. It's a lot of algorithms. To subtract double-digit additions, you stack them on top of each other. You subtract these numbers. You take the first number, put it on the top. It's just a purely a procedure that students would go through. And so there's a lot of emphasis in the early, in the bad old days on simple calculation. The main emphasis of Singapore math was to move away from simple calculation and go a lot more toward problem solving and conceptual understanding. However, I also want to point out that doesn't mean that they've given up memorization or simply knowing your math facts, like your times tables. So they really do both. It's not one or the other. They emphasize understanding and problem solving, but they also believe that mathematical fluency is important. Believe me, you're not going to visit any of these high performing countries in East Asia with kids not knowing their times tables. They absolutely do. And that's something that's been given up somewhat with more recent trends in the United States. So we do both here. But a few of the things that Singapore Math does really well is it focuses on mental math. It really wants the kids to be able to play with numbers in their head. If they really understand how numbers work, then they can manipulate them in their minds. They can do math problems mentally. And we do word problems consistently, starting in first grade and even some in kindergarten. They are using words to think about math. They're doing real life applications. The entire curriculum is based on problem solving, as we've mentioned, and logic and number sense are emphasized. And number sense is really, do kids have a sense of what numbers mean? If I say, 247 plus 350, if you have a number sense, you know about, it's going to be maybe 500, 600. I've got a sense of what the numbers mean and what appropriate magnitudes are. A child who has no number sense, you could say the answer is 1,000,000 and they wouldn't bat an eye because the numbers don't really mean anything to them. So having kids really understand the sense of what numbers mean is a part of the curriculum. You can imagine that high school teachers love students who have been trained in Singapore Math because they start with algebraic thinking early on, the problem solving, the conceptual understanding. This is what really does lead students to higher levels of achievement throughout their academic career. The 3 stages of learning in Singapore Math are really the foundation of how Singapore Math teachers work. The 3 stages are concrete, pictorial, abstract, which are illustrated here. With concrete, it is hands-on. Students should always, especially in the younger grades, in the primary grade levels, kindergarten through 2nd grade and 3rd grade too, they start by using real objects to solve problems. This is really important for that number sense, again, and for that conceptual understanding. We start with them trying to solve problems using objects so they know what they're doing. The next step is pictorial, where they'll represent what they did using a diagram, a model of some kind. So in the picture, they use those linking cubes. If we're giving them a problem where they're adding 7 objects to 3 objects, they can use the linking cubes to physically do it and play with it. The next step is they'll use diagrams, pictures to represent what they did with real objects. And then the last step is called abstract. And that's these strange symbols that we see here, this upside down L and this squiggly line. Of course, to adults, it seems so obvious, 7 plus 3, this does not seem very abstract to us. However, that is abstract. And young students have no idea what that means until they've really gained a lot of experience with addition, subtraction in real life and knowing what it means to say 7 plus 3 equals blank. I will mention about these 3 stages of learning that they tend to drop off a little bit in the upper grade levels. Once students have a really strong foundation in pictorial and abstract thinking, that doesn't mean they always start with concrete objects. It gets kind of increasingly hard to do that with some algebra and some other mathematical concepts. But for sure, in the early grades, we emphasize this 3-step process. A lot of kids do number stories. They think about numbers. So looking at this picture, you'll see on the bottom right, there's a 6 with the 2 lines and 2 circles by it. That's a number bond, which we're going to talk about in a little bit. We encourage students, again, to play with the thinking of math. Looking at this picture, what's a number story that you could tell? And a number story just means, how could I mathematically describe what I see here? Okay, the 6 is the number of students, but what story could I tell about that? Well, there's 4 students on the seesaw and 2 stories, 2 students on the swings. So that's a number story. That's just using numbers to describe something. And the 4 of the seesaw would go in one of the smaller circles, and the 2 from the swings would go in the other circle. That's just showing that we've divided up these students, we've decomposed them into 2 different groups. I'm going to pause. I want you to come up with a number story. I came up with the simplest one perhaps, but what other number story could you tell about this picture? When you've got one, would you unmute and share it with us?
I could say that there is 1 with a hat and 5 without a hat.
Excellent. Any others?
I can say that there's 3 girls and 3 boys, if I'm
There
not
we go.
mistaken.
I believe you're correct. Good. So they can decompose 6 into 3 and 3. They could decompose it into 1 and 5. As students play with this thinking, they get more and more sense of numbers. So this number bond, thank you for your participation. This number bond here is something that you're going to see a lot in the early grades in Singapore math. And we're going to talk a little bit about why it's so important. So this idea of a number bond is simply a graphical way to represent that a number is composed of parts. That, for example, let's see, I'm gonna mute somebody there. For example, a 10 can be decomposed into a 3 and a 7. And this one simple picture can represent many different ways of presenting that fact. 3 plus 7 equals 10. 7 plus 3 equals 10. 10, if you take away one part of it, the 3, you're left with 7, or 10 minus 7 equals 3. So these number bonds allow kids to think about numbers in a way that represent the facts about the numbers, but also can be interpreted into different number sentences. They work with these number bonds a lot as a way to really reinforce the relationships between addition, subtraction, between numbers and their component parts. So I use that word decompose or decomposition. That's going to be really important in Singapore math, which we're going to see next. So if a student, this is kindergartner, first grader, is adding 8 plus 6. The traditional method, at least the way I was taught, was, start with 8 and maybe count on 8, 9, 10, 11, 12, 13, 14. I'm maybe using my fingers and I get to 14. In Singapore math, if students are really comfortable with those number bonds and decomposing numbers, they could probably figure out a mental math way to solve this, which would be to make 10. This idea of making 10 is going to be really important. So 8, well, that's close to 10. I know, because I've played with number bonds, that 6 could be represented as 2 and a 4. And the reason I would do that is that now I've got a 2, and I know 8 plus 2 equals 10. So that means I've got a 10 and a 4, and 10 and 4 is easy, that's 14. So this is just a simple way to illustrate how those number bonds then come into play later as they're doing mental math. Here you can see it in a slightly more sophisticated way. 88 plus 76. Well, if I can make the next 10, that usually makes addition easier. It gets really, kids get bogged down, 88 plus 76. It's hard to keep track of the 10s place and the 1s place. But if I could do it adding on to 90, that's a lot easier. Okay, so 88, I only need 2 to make 90. So let's decompose 76 into a 2 and a 74. Okay, now I've got a 90 and a 74. Well, that's a lot easier. That's 164. This comes into play with fractions. 5/7 plus 4/7. Some kids might get stumped with that, but if I can make 1, then it's easy, because adding to 1 with fractions is easy. So how do I get to 1? Well, 5/7, I'm 2/7 off. So let me just take that 4/7 and break it down. That's 2 2/7. Okay, the 5/7 and the 2/7 together, that makes a whole. So now I've got a whole plus 2/7, and they've been able to do that mentally. So a lot of, we hammer something called place value. This is something that your kids are going to see all through 3rd grade into 4th grade. We really think about place value a lot in Singapore math because it's so foundational to mathematical understanding. So I'm going to show you some examples of how this works and why it's so important. You're going to see this hundreds, tens, ones chart, I hope, in what your kids are doing. They work with this a lot in class. So let's start with the number 99. How do they show the number 99 on this chart? Well, there's 9 tens and there's 9 ones. You add the tens and the ones together, you get 99. The most efficient way, that's the fewest number of markers that the student could use to make 99. Now, we'll look at how this hundreds, tens, ones chart, how that comes into play when they're actually solving problems. Let's say we give them 99 plus 5. The way we could show that the way they would show this in a concrete way as they're starting these types of problems is to add 5 singles into the ones column. That represents 99 plus 5. Now to get my answer, I know that that doesn't represent a typical number because when we got ones, once we get up to 10 ones, then we transfer over to the tens column. So, okay, we put all the ones together. Now let's count out 10. I can count out 10 of those and I trade in my ones tokens for a tens token. And I'm still left with 4 ones. Okay, there's something wrong here though. Can anyone see what might be wrong with representing it this way? Feel free to unmute if you see what the student might need to do next.
Trade in for 100.
Exactly. They know that once you got 10 tens, that equals 100. So we're trying to always find the most efficient way. Yes, this does technically represent 104, but they know to transfer between the different columns. So 10 tens makes 100. Now we've got the most efficient way to represent 104. Let's look at another way, another quick problem. 143 minus 7. Okay, we've got 100, 100, 4 tens, 3 ones here. That represents 143. If I want to take away 7, what would I do? I don't have 7 ones. I could take away 3 ones, but I don't have 7 singles. What could I do?
Send and receive.
Trade a
Miss
10
Bigley.
in for 10 ones.
Exactly. Kids are getting used to playing with place values. So I'll take one of those reds, I'll trade it in for 10 ones. Okay, now I can take away 7. Now I'll count up 7 of those blue markers and take them away. Now I've got 136. As kids play with these tokens and these place values and really get comfortable with switching between the different place value, they're understanding what they're doing when they get to the algorithm. So the algorithm is the way that we probably learned as kids. Put the 143 up here, put the 7 under it. You've got to borrow from the 4. Well, what does borrowing mean? Most of us really didn't learn what it meant when we said borrowing. When kids use physical tokens and do these exchanges, they know exactly what's happening when they're borrowing. They're taking away one of the tens tokens and swapping it out for 10 ones. As they do this repeatedly, it really reinforces the understanding of what it is they're doing. It makes it so they can solve new problems. They don't get just stuck if they forget the algorithm. It gets more complicated too. This is exciting. When we get to multiplication, all right, 143 times 3, they can just make 3 143s. They know how place values work, so you could probably guess what comes next. We've got to make this in the most efficient way, right? Can somebody unmute and tell me what would you do next to solve this mess of tokens? I'm looking.
Group the 10s.
We've got that tens column there. Definitely more than 10. We've got 4, 8, 12 of those. So we've definitely need to trade out 10 of those for hundreds. If we've got 10 tens, that means we've got another 100. So 300s. Oh, there we go. Actually, that was just condensing them together. And now we'll swap out. Now we've got 400s, 2 10s, and 9 ones. So we have an answer. Ooh, division gets interesting. When we divide things, what we're doing is splitting it up. So how do we split up 100? We've got that one green token and we're not giving the kids scissors. They're not going to cut the tokens. They've got to figure out some other way to do it. So the way they do it is they swap out their hundreds for tens. Now maybe they can divide that up into 3 parts evenly. Looks like they actually can. Now they have an answer. We've got 61. Okay, when it comes to concrete, this is also helpful when it comes to fractions. Again, most of us learned maybe simple methods like when you divide by a fraction, you flip it and multiply it. We learn these just routines and procedures, and we don't really understand what's going on. When you think of 230, or sorry, when you think of 2 3/4 divided by a half, what does that even mean? Well, as they learn in Singapore math, they learn that it's asking how many halves. So that's how many halves are in 2 3/4. Now they use concrete objects to represent to represent fractions. So, and they're using decomposing. So let's decompose. The 2 3/4 is the same as a 2 and a 3/4. Let's just focus on the 2 right now. How many halves are in 2? We've got 4 halves there. Okay, now let's look at the 3/4. There's 3/4. How many halves are in 3/4? Well, you've got 1 half, and then you've got another thing sticking up, which is a half of a half. So you've got 1 1/2 halves. So we had 4 from before, and now we have another 1 1/2. That means we've got 5 1/2 halves. So by using the concrete objects, it really kind of demystifies some of the work that they do with fractions. The last, I think this is the last big strategy that we're going to talk about today, is bar modeling. Bar modeling, it's a powerful approach to problem solving, and students will use it repeatedly. I think they're introduced to it, well, they're introduced to it pretty early on, and it's only going to become more important as they get into 4th, 5th grade and up. And it's a really simple concept, but it's a very powerful concept for helping kids think about what they're actually doing when they're solving a math problem. So here's an example. Maria went shopping. She spent half of her money on a book, half of the remainder on a pen, $2.50 on a notebook, and she had $3.50 left. How much money did Maria have at first? I'll let you think about that for just a moment. Now, a lot of students are going to be overwhelmed by this kind of problem, right? This is a lot of steps, it seems like here, and man, a lot of kids might just throw up their hands and say, I don't know, I don't even know how to figure that out. What bar modeling does is it helps students break it down and conceptualize what's in the problem. So let's look at what that would be for this 4th grader. The basis of the bar modeling is, let's start with the bar. This bar represents Maria's money. She started with this amount of money. We don't have to know what it is yet. We just know that this represents how much money she started with. Well, what's the first thing we can do? She spent half of her money on a book. Okay, half of the remainder on a pen. Well, let's cut this in half, and we're just going to say half of it was on the book. And we know that half of what's remaining went to a pen. So let's cut that in half and say that's what she spent on the pen. Now we know that her notebook was $2.50, and she had $3.50 left over. So $2.50 plus $3.50 is what we've got left over there, $6. So $6 represents a quarter of how much she had to start with. So 6 times 4, we solved that she had $24 to start with. It's a simple method, but it really makes something that seems overwhelming at first manageable. Here's an example from 5th grade. The ratio of the number of Jimmy's marbles to the number of Kelvin's marbles was 3 to 4. After Jimmy bought another 60 marbles, he had twice as many as Kelvin. How many marbles did Jimmy have at first? Again, a very tricky problem. Could seem overwhelming. So let's start by bar modeling. We've got Jimmy's marbles and Kelvin's. It's a ratio 3 to 4. So we've got Jimmy had three units. We don't know how many are in each of those, but we know that Jimmy's got 3 to every 4 that Kelvin had to start off with. But then he bought another 60 marbles, and that gave him twice as many as Kelvin. Okay, so Kelvin, we're holding steady. He's got those 4 units, however many that is. Now Jimmy has twice as many. So how many units are we gonna have total on Jimmy? We'll have 8. Okay, this gets a little complicated on the screen here, but when we add the 60 marbles, we can think about it as now he's got 4 more of these units than Kelvin. He had to first make up the first unit that he was short and then add 4 more to get to double the amount. And so if you know 60 divided into 5 different parts gives us 12, then we know that each of those equal units represents 12 marbles, and we can figure out that Jimmy had 36 to start with. So kids do get to this level of sophistication. Maybe seeing this for the first time, you're like, well, that's pretty complicated. But as they use this strategy again and again, they're able to solve more complex problems. All right. Let's see, are you smarter than a fifth grader? Maria won a cash prize. She spent 3/8 of the prize on a washing machine, 2/5 of it on a refrigerator, $180 on a fan. If she had $270 left, how much was the prize? For those of you joining us at home, I'll give you a minute to think about it. I know some of you might be in stores or driving, so you won't have the chance to solve it, but I'll just give you a little bit of time to think about how would you solve this. Are we stumped yet? Here's the Singapore approach using bar modeling. First, we'll divide it into eighths because we know she spent 3/8 of it on the washing machine. The big bar here, this is just our bar model. We know the total amount is this big rectangle. We'll divide it into eighths, and we're going to say that 3/8 of it went to the washer. So we'll mark off those 3/8. Now we need to divide it into fifths because 2/5 of it was on a refrigerator. So to cut it into fifths, if we go the opposite way, we won't interfere with our eighths marking. Okay, so now we've got it divided into fifths. 2/5, well, 1, 2, 3, 4, 5, 6, 7, 8. One column of a fifth is equal to 8 units. 8 of those are little rectangles. So we need 16 of those rectangles to make 2/5. So we don't want to overlap with the washer. That money was already spent, but we're gonna put in 1, 2, 3, 4, 5, 6. There we go. We've got 16 blocks filled in. That represents 2/5 for the refrigerator. All right, now we've got 9 blocks left over. Well, we said that the fan is 180 plus what's left over is 450. So 450 is the remainder. We've got 9 units left. So that $450 is divided equally among those 9 units left over, and that would equal 50. So if we know that each of those little rectangles is worth $50, now we can get our total because we can do our math here and figure out that there's 40 total blocks. So 50 times 40, we've got a total cash prize, $2,000. Pretty sophisticated problem, but as kids master bar modeling, they're able to take on challenges like this. So now that's just an introduction to some of the methods and approaches that your child will see with Singapore math. And I'm going to talk a little bit about how you can support us. You don't necessarily need to be an expert in bar modeling or number bonds. However, there are some things that you can do that are really helpful and important. First of all, math facts. I mentioned at the very beginning that Singapore has not rejected the notion that kids should know their math facts. This is important. And I like to compare this to reading. What we see with students who come into Monticello later, or maybe occasionally a student who didn't retain their mastery at Monticello, what we see is that some students, they still don't know their math facts. They might not know their multiplication tables. So when we see in 5th and 6th grade, these students who have a complex math problem, like what we just saw with the refrigerator, we want to free up their thinking to think about the problem itself. But too often what we see is kids still struggling with the addition and the multiplication, and they have to pull out their fingers and they have to take, it's very frustrating, time consuming for kids who don't know their math facts. So we need our kids to know those facts on the tips of their fingers so that they're not bogged down when it comes to problem solving. We have standards in each grade level for what we want our kids to know on the tip of their tongue. I was going to make a comparison to reading. Think about reading. If your kids don't know their letter sounds, how easily will they be able to read? If they're having to stumble over and remember, oh, the B says ba, d. Okay, bed. Obviously, that's one phase of reading. But if kids stay in that phase and never just master that phonics, they'll never be good readers. And we draw that as an analogy to math. If they never master the bare facts of addition and multiplication and subtraction, then it will be very difficult for them to be proficient at mathematics. So this is something that's, I think, unique to most schools. Is a lot of schools have given up on math fluency. They think it's boring and rote and unimportant. We think it is important. It actually helps them to achieve higher levels of math understanding. So your teachers, if they haven't already, they're going to be sending out the standards for what your child in his or her grade level needs to know, what they need to know on the tip of their tongue. You can do this at home, and this is a great thing to do at home. We actually don't want to spend much time at school with this because we want to focus on the harder problem-solving skills. This is something that's easy and great to do at home. You can use flashcards, a deck of flashcards. Let's say, third grade, they're doing their multiplication facts. Those tricky 7, 8, and 9 multiplication facts. Use flashcards. Dice, if they're working on, again, multiplication, they can roll the dice and say what's the product of those two numbers. We think talking about math regularly, bringing math into everyday life. Number 5 says drill and thrill. I know there's, these timed drills have maybe a bad reputation in some places. They say drill and kill. Well, what we see is that kids actually really enjoy seeing their growth. This is an area where it can be really clear to the kid that my effort is going to lead to achievement, because last week I could only answer 5 questions in a minute, and this week I can answer 10 questions in a minute. So we would prefer to call it drill and thrill. This is a way for kids to just measure their growth as they're getting more and more proficient with their math facts. We have some internet sites. If you want some ideas, we use Imagine Math Fluency, which has little games and activities for the kids to master their math fluency. And timing is a part of it. Again, the timing is important, because if kids don't have it fluently and at their fingertips, then it just bogs them down when it comes to math all along. Money is a great opportunity to think about math because it's so real life, directly applicable. Kids can understand the concept of, it's similar to place value, trading out 10 pennies for a dime, trading out 10 dimes for $1. So I would encourage you to just, as you're maybe waiting in line, do a quick math problem using money, using real coins or just verbally. Measurement. The more we can bring numbers into real life, the better. As you're baking, doing recipes, have your kids help you, challenge them. Well, if I need 3/4 a cup of flour and we're going to double this recipe, how much flour do I need? Let them wrestle with it. Let them grapple with math as much as possible in everyday applications. We believe that students' attitudes toward math are very important, and often they catch a bad attitude toward parents, unfortunately, because some of us were not taught well and we might feel inadequate with math. So we would really appreciate your help by not giving messages like, I was never good at math. Oh, I don't like math. I don't have a math brain. That last one in particular is the worst, because we're trying to teach kids that our brains are plastic. They are malleable. We can grow as we practice. We can become better at math. And if you say something like that, that's sending the exact opposite message, that we can't grow in math, or that it's an innate and fixed characteristic. In fact, I would add to this that I really believe in not telling kids that they're smart. If you tell someone they're smart, that's a fixed characteristic that they don't have influence over. What that does is it makes them think, well, if I'm smart, I don't want to disprove that. If I struggle with something, maybe that means I'm not smart. So that can lead kids to be risk averse, to not want to engage in hard problems because they don't want to disprove the idea that they're smart. They don't want to encounter the idea that they're not smart. We want to reinforce effort. So we would much prefer that when a kid does something well in math, you say, I really like how you thought about that. I really like that you didn't give up. You found a new way to do that. So reward things that are within students' control, reward their effort. Try not to say that they're smart at math, because as we know, everyone can grow at math. Bedtime math. This is something I started with my own kids several years ago. I encountered this book, and it's just a nightly, instead of a bedtime story, we give them a bedtime math problem. I've since gone past the book. I don't use the book anymore, but my kids insist on a math problem before they go to sleep. My first grader won't fall asleep until I've given her a math problem. And I have seen just those daily 2-3 minutes of thinking about math. I give them word problems. I think of problems related to what they've done in the day or what we've been seeing, or, we've been noticing the birds in the backyard. If there are 5 on the feeder and 2 fly away, how many are, just finding real applications and giving them these little math problems. I've seen a huge difference. Their attitude toward math is great. They feel like they're mathematicians. They enjoy solving these little math puzzles. So again, you can also help with reinforcing math facts, helping at home. And I will mention a little bit more about that, which is that in late February, we have the Math Fluency Olympics. Students take a timed math facts test. They have the opportunity to earn gold, silver, and bronze medals, depending on how many correct answers they get in 1 minute. I'm pretty sure in every grade level, if they get 25 facts per minute, that's gold, 20 is silver, 15 is bronze. And of course, the types of facts change in each grade level, but I'm pretty sure the standard stays the same. They should be able to do 25 in a minute. That's exceeding mastery. That's awesome. We do this in February to give us a benchmark before we get to the end of the year. We need them to be at grade level by the end of the year. So we do this fun Olympics in February just to see where they are. If they're there already on gold, silver, they're going to be in good shape. And then we can also push them. If they haven't made it, then we can make sure they get there by the end of the year. As I mentioned, teachers are going to send out some details about this for you soon. And I want to make sure parents understand that just because we have this emphasis on fluency with you at home, really that's because it's such an easy and good thing to do at home. That doesn't mean it's all we do. We really focus on the problem solving and the conceptual understanding here at school. That's something that's might be harder for you to do at home, but the math facts you can absolutely support with at home. All right, that is the end of the formal presentation, and I'm just going to open it up to any questions people might have.
And I'm sorry, I came in late.
No problem.
But I was hearing that you were saying about a bedtime stories, and you were looking into like the daily stuff that you guys were doing. So how would you incorporate that? Like, cause I have like different ages, cause I think that's a great idea, especially
Yeah.
kids have a hard time with their maths.
Perfect. Good question.
So how would you do that with with them if they are in different age groups?
Definitely. In that bedtime math book, it has similar questions for 3 different levels. So it'll start with a interesting little snippet, for example, about hot peppers. And it talks about Scoville units and how we measure the heat of peppers and how we can measure the heat of peppers. And then it has a question for the bitty ones, a question for the middle, and a question for the high. So I can use the same book. I've got a 1st grader, a 3rd grader, and a 5th grader at my house. I can use the same book, and it might ask my 1st grader, if there are 12 jalapenos in the contest and Johnny could only eat 4, how many are left? And then it has a higher level question that might get into double digits or a little bit of multiplication. And then there's a higher level question for my 5th grader. So that book is a good resource. It does have it differentiated so that you can use it for different ages. And then in terms of like my bedtime routine, I tuck in each kid and I give them each a different math problem based on kind of where I know they're at. So that's just one suggestion though.
Okay. Yes. And also, because I know there's some math at the beginning that I was not able to help my daughter I guess, because we did look through YouTube videos and I was trying to help her with some of her math problems. Mm-hmm. And I had a question there. So I know you said that to help our kids by telling them it's great for their, to provide more of an effort praise for them. Mm-hmm. And so, and in case we don't find out how to resolve that math problem, is there something like that there can be done, like instructions on how to do their math problems, so us as parents can be able to help them out in that kind of way? Or what other options would there be?
Good question. I think that's important to recognize that sometimes sometimes we do fail to get a solution, or we might run into something that we can't figure out at the time. I think it's really good to send kids the message that of persistence. Well, you know what, this is tricky right now. Let's see what resources, you know, I'll ask your teacher. I do definitely encourage you to reach out to the teacher if there's some aspect of it that you are unsure of, that you can't figure out. I would like in this presentation to have given you exact resources to go to, but it's going to be a little bit different in each grade level. But I definitely encourage you to keep an open line of communication with the teacher. If something isn't making sense to you, let them know, and they can either point you in a certain direction or just clarify something. You know, maybe you see those 3 circles, those number bonds on the homework, and you're like, I have no idea what this means. That could be resolved pretty quickly, you know, once a teacher can just explain how to use it. So I just encourage you to reach out to the teacher, and in terms of our messaging to kids, we can reinforce, oh, I really like that you've tried, you know, we did our best with this, and that's okay. And let's see what other help we can get.
Okay.
Hey, Dane, we actually came across that same question in parent council. We were thinking that maybe we could do some of the trust money with having like a teacher post about how those math lessons were going, so that, or do like a Zoom meeting to where parents can join in and say, this is kind of what we went over, and this is how we did it, and this is the way we need to teach it.
Mm-hmm. Yeah, I think that's a great idea. And that's something that will be common among grade levels. So we can bring that up with our teachers. You know, in first grade, there might be a common set of questions and parent solutions. So the first grade teachers could put their head together and maybe do a guide to first grade math and what you need to know as parents in first grade. So thank you. I'll write that down. I know we've got some feedback coming from parent council about that. So thank you.
I have a question.
Other questions?
Yeah. So about like the questions and how we can help the kids solving them. I have come across a couple of questions with my daughter that she was struggling, and she told me about some tests that she said like they didn't see or cover them in class, but still they were in the test. So what I figured out is
I'm really glad you brought that up.
Yes, like the videos of the tests are all for this, like maybe they share the, I don't know, they share the tests in, like for example, my daughter is in 2nd grade, and there's 2 2nd grade teachers, and one teacher made the test, but not the 2 teachers covered them. That's the same, I don't know, the same problem of the same solutions. I don't know,
Right.
but one teacher didn't cover it, and still the problem was in the test, and then the kids didn't know how to solve it. So that
Right.
happened
Okay.
a couple
There's a
of
couple
times
things
already.
I want to say about that.
So, and that's a concern because
Right.
I mean, I
Okay,
help
so
her
the first thing
understand that,
is,
but I think
yeah,
that's not kind of very fair on that.
very fair. Right. You're kind of breaking up a little bit, but I definitely got the gist of your question. So that's something I probably should have mentioned in the presentation, is that one of the aspects of Singapore math is that when they take assessments, they will include something that we call zingers. The zingers are questions that are a pretty high level, that require a high level of understanding and applying that understanding in a new way that they often were not exposed to in class. Now, as an educator, I have mixed feelings about these zingers, okay? In the perfect world, students are always prepared for what's on the test. That just seems like a natural thing. The Singapore philosophy is that if we really build their conceptual understanding, they should be able to apply it in a new way that they haven't encountered before. In fact, a problem, some educators define a problem as something that the students haven't seen before. If they know exactly how to solve it, if they have a memorized procedure for how to solve it, then is it really a problem? It's not a problem. A problem is when they see something they've never seen before. So the first thing to answer your question is that it's very possible that none of the teachers actually taught the students how to solve that to solve that kind of problem. There are zingers in our curriculum. The tests will throw these out, and a lot of kids might get them wrong. We've been having discussions among staff about what should we do with these zingers. So number one, we have a 4-level grading system. The 1 is not yet, the student's still far from mastery. The 2, or the yellow in Mastery Connect, is almost there, almost at mastery. The 3, or the green, is met mastery. And then the 4 is exceeds mastery. That's the blue level. One thing that we've done is said that those zingers, that's the way you get blue. That's the way you go above the standard, is if you can really take this knowledge and apply it in a new and creative way, then that's exceeding mastery, and that's the blue. We don't expect all students to get blue. That's going beyond, again, mastery. So the first thing I'd say is you don't necessarily need to worry too much. If your student has missed some of those zingers, that doesn't mean that they haven't achieved mastery, but that might mean that there's another level for them to strive for. The second thing I'll mention about that, though, is that at least in some grade levels where we've been having this discussion, I've encouraged teachers to try to teach to that level. Even if we're not spending, it's okay to have kids struggle and really try to figure something out. But we also want to provide the ladder for them to get to the highest level. So in the grade levels I've spoken to, they are planning to do more instruction toward that level of question, at least hit it in the review as they're preparing for the test. They can at least give kids some tools to say, hey, if you see a question like this, what are some ways you can think about it? Let's think about it together, give them some support for how to solve those types of problems. We do weekly data meetings, and our teachers will review the data together. If they see one class solved all those zingers and one class didn't, that's going to be a conversation they're going to have as a team to figure out, what did this teacher do effectively that this teacher didn't, so that they can reach parity. As a mastery grading school, that also means that students, if they missed it the first time, that doesn't mean they're locked out. They can retake an assessment. A couple weeks later, once the teachers reviewed it, parents maybe help them, they can take that assessment again, and whatever new assessment grade they have replaces the old one. So there's always an opportunity for students, after we look at the data and we see how we need to change it, students can have another opportunity to demonstrate mastery, and it will just erase the previous grade. So I hope that addressed your question.
Yeah. Oh, well, what I noticed on that one, and I'm not against it, is that maybe as you said, maybe the teachers can give them like maybe a little bit more of tools to help them solve it, and they're more ready to solve them. And also, like, for example, my daughter gets really frustrated, and she also cries a lot with those ones, and she gets stuck on that, and then she doesn't work on the rest of them.
Mm-hmm.
So she wastes too much time on those, and then she doesn't finish the rest of the test. So that's a problem for me, and for her. So that's a little bit of a frustration for her. Like she didn't have time to finish the rest of them because she was so focused on that one exactly. So maybe if the teacher can maybe let them know, okay, if you get stuck on them, just keep going and then come back to that one or something like that.
Yeah, that's a great suggestion, and I would encourage you to reach out to your teacher. It's part of what we try to do with building a growth mindset, is building that resilience to move past those problems and those challenging parts. But I definitely encourage you to reach out to the teacher and see if they can help give that push.
Yeah, well, that's something I've done before.
Okay.
But yeah, it's been a couple of times that happened to her, and she's like, "Oh, Mom, I didn't finish because there was this problem. I didn't know how to solve it," and that happens a couple of times before. I'm like, "Oh, interesting."
Yeah. Thank you. Are there any other questions before we sign off here? Well, great. Well, I appreciate everyone being here. It's great to have so many parents who are interested in learning more and being able to help their children. And like I said, we'll have teachers sending out information shortly, if they haven't already, about our upcoming Math Olympics. And we're excited about the rest of the year. We're excited to be back in person with everybody in January, and the teachers are super excited to make the most of that semester. So thank you all for attending, and we'll see you later.